All right, folks, welcome to Beyond the Noise, Signals, Stories, and Spicy Takes, the show where we dig into the stories of the people shaping the future of app-based computing with a special focus on mobile. I'm your host, Matt Klein, co-founder and CTO of BitDrift and creator of Envoy. Each episode, we'll talk with engineers, founders, and technical leaders who've transformed the way their companies build and understand what's happening inside their systems. We'll dig into the challenges, the breakthroughs, the lessons learned, and wrap it all up with their hottest takes. So let's dive in. Today, I'm thrilled to have P-Y Ricau, who works as a principal engineer at Block, the company previously known as Square. He's been having fun with Android for the last 16 years and has more recently been focusing towards performance and observability. Thank you so much for joining us. I just want to say I'm very excited. For those of you, probably most of you listening do know, PY is a legend in the Android community. So very, very excited to have you. Thank you.
Thank you, Matt. That's love to hear that. Thank you for the great intro. I'm excited to be here.
Yeah. I think the way that we typically get started is, you've had a very exciting career. You're obviously extremely well known in the larger mobile community. You also have done a lot of open source, as I have, so we can talk a lot about open source and the pain and the glory of that as well. But would love to start by just understanding, a bit about your career, how you got started in Android, what excited you about it. So give us the breakdown of just how you got into this space.
So I got into Android in 2009, kind of accidentally, really. It was my first internship out of college. I was still in college, actually, at the time. And the last internship. And my boss was like, hey, can you try this new thing called Android and just build a sample app? He had bought a G1. And so I did that and I was hooked. Though at the beginning, I wasn't sure I wanted that to be my career because I was doing Java backend code, and I thought that was where the real engineering was. And so I thought Android wouldn't be like serious engineering, and I wouldn't have a very serious career if I did that. But I was hooked from the very beginning because of the ability to write some code and immediately see something on the screen and touch it. It was really, really nice to get that sort of like toy aspect of like playing with things.
Yeah, I mean, I've said this on a couple of different calls at this point or podcasts, but most people don't know. I actually also got my start doing mobile development. I mean, my career,
Nice.
I'm known as a back-end infrastructure engineer, but I actually started working on Windows Phone. So this is pre iPhone, pre Android, and I also remember the same feeling is that it's really fun to hold that thing in your hand, and I'm sure you would agree that the engineering involved in these constrained systems, I think in many ways is more complicated than what has to happen on the back end.
Oh, I don't want I don't want to get into that fight. I think I think today's writing backends has evolved from, just writing a little controller or something to like dealing with infrastructure and a whole bunch of different
Sure.
things that I
Yeah.
have no idea how to do. Um, so yeah, it's just different types of complexity. But, I know that we're typically blind to the things we don't really know, right? So if you're not a mobile engineer, you might be going, well, how hard can it be? It's just a couple screens, it's just buttons, you know, and then you end up at Square where we have, mono repos for like a single app that's like millions of lines of code and hundreds of contributors every month. And it's a lot of complexity that you have to handle.
Yeah, of course. So I would absolutely love to get into that because I think most people would be fascinated to know what are the big challenges that you're facing there and what are the big trends that you're seeing in this space. But before we do that, I'd love even just to step back a bit, and you talked a bit about your internship. I'd love to know kind of the early history of how you wound up at Square and Block, and just tell us a little bit about, obviously, as I mentioned before, you're very well known in the Android community. I think a lot just for a lot of the open source work that you've done in the space and your general leadership. So I just I'd love to explore a little more
Yeah.
how did that happen, right? It's like, how did you wind up there? How did you, get the ability to actually have a lot of that industry focus?
Yeah, that's a good question. It's it sort of just happened. I've done open source for a long time. Even before I was out of college, I started. It was just just made sense, right? Like share your code with others, because before, when you're not working yet, you don't know what to do with your code. You just wanted to share it with the world. So I was doing open source back then, and I just got in the habit of doing that, and I liked sharing what I learned. So presenting, and so I think that sort of went together with that. The big milestones for me was where before. So one of my early successes on open source, I guess success, like early project with adoption, was something called Android annotations. And it was a little ridiculous. What happened is I went to a Java user group one night, and someone was presenting annotation processing. So you put annotations in code, and you get a little bit of some sort of, it's kind of like a compiler plugin, some code that executes and it compiles and lets you at compile time and lets you generate more Java code. And I used that to create something that in a way was similar to Google Web Toolkit, because I'd been using Google Web Toolkit at the time, and there were some nice utilities that I liked from that I didn't have on Android. They had ways to tie the UI to the code and those kind of things. And so I built this thing called Android annotations when I wasn't working on Android. I was doing Java backend at the time. And it was just sort of like a side project to sort of like play with things. And it sort of took off. And I was always surprised because I actually never really used it. And what led me to the next big step was that one of the things that had been my goal at the time was I wanted to build a DI tool that would work at compile time, mostly because I had seen the Java spec for that, the at inject spec that had a little comment at the end saying, hey, you could also do this at compile time. And I was like, oh, annotation processing, I can do this. I could never do it. I was just not smart enough. I couldn't figure it out. And then Square released Dagger, which was exactly that. So when I saw that, I just posted a little GitHub issue saying, like, hey, this is cool. Can you make like a plugin architecture? Because I want to integrate your thing with my thing so that I don't have to deal with DI. You're doing it. And Jesse Wilson, which is a big open source, it's got so much impact in the community, right? He just emailed me and he was like, hey, are you interested in joining us? And that's how I joined Square. And that's basically the story of me joining Square. Is just I filed a GitHub issue, and he was like, "Do you want to interview?" And yeah,
Yeah, it's funny because I've given a lot of career advice over the years, and I think it's not uncommon that happens. And I think a lot of times when I'm talking to younger engineers and they're asking, I don't know, it's like, what's the best way of finding a job, or how do I do this, or how do I do that? And I do think a very real strategy is getting involved in open source. It's like the number of people that I've seen get jobs through even small contributions, just because people are always looking. And it's such a great way of almost doing like you're almost doing an interview. I mean, it's like if you can write the code and you can comment respectfully on the PRs and all of those things, it's a great way of learning about someone before they show up.
It's one of the things where maybe if it's okay for that to be in the back of your mind, but it shouldn't be your main driver for like doing open source, because you're gonna get tired fast. But it is one of the ways that you get in. And so I joined Square, which for me was like, this company that early on. So the thing with Android, if you're not a mobile engineer, you might not know that. Google was working on Android at the same time that Apple was working on iOS, but Apple got there first. That put a lot of pressure on the Android team at Google. So for a couple years, they were basically catching up, and that meant that they were focusing on shipping a lot of features really fast, not focusing on designing the best APIs ever, building the right frameworks, and all of that. And that left a big gap in the Android community. And add to that the fact that a number of Android developers, because Android was Java, a number of first Android developers were Java backend engineers. And they were used to like Spring and all of their frameworks and utilities. And so people were trying to fill that gap. And so Square very early on started building a lot of tiny libraries that were incredibly useful. And so to me, Square was like this amazing company. I had no idea what the business model was, like what Square was doing. I just knew they did open source. So when I got the opportunity to join, I jumped in and started, contributing there.
Well, I was just going to ask. I mean, because you joined relatively early at Square, and I guess I actually don't know this. Do you know how did Square choose Android? Right, because it's a pretty young company picking a pretty young technology. So I don't know. Like, do you know the history of how that happened?
I think it just is a happy. I mean, it's not an accident, but it's what happened is Square hired Bob Lee as a CTO. I think back, I forget exactly when, maybe 2010, maybe around those times. And he had been working on Android at the time, and he was one of the local celebrities in the Java community, doing amazing talks, and his job as a CTO was a bit more outward focused than you'd expect. His job was basically make some of the best engineers want to work in this company.
Yeah.
And so he did that. And he did that through open source, like fostering that culture, and then through public tech talks. And so I think it wasn't so much a choice of Android, but rather a CTO that had a strong Java background that brought in a number of folks. And for Android, we just hired, we typically, there wasn't really many people who had Android background. So we just hired,
Right. Yeah.
very senior Java developers who had open source background, and we just learn Android on the job for the
Yeah.
most part. And so I think that's how the focus came, and then we hired like Jake Wharton, Jesse Wilson, a number of folks like that, Ray Ryan, they went all in on this. It's just the way that they work, and it created that culture. One thing that was really interesting and surprised me is that there was never a clear, like, it was part of the engineering culture and something that would be repeated, but not something that was anchored in processes. Like, we didn't have an open source manager or any role like that, or
Yeah.
anyone thinking strategically about all of that. We just had people doing open source.
Yeah, I mean, I think it's a fantastic way of doing things. I would imagine though that very early on you were having to build a lot of these niceties on top, but I would imagine you were dealing with a lot of platform bugs as well. I mean, because I mean, it's pretty early on, right? So as you said, they were shipping fast. So I'm just curious, I mean, I actually love bug stories if there's a particular early bug that you want to share, but more generally, what was it like to work, on the platform that early? Because I would imagine that, Square and Google during that time, I would imagine that you became a fairly important customer to them, right? So it's like I would imagine that you work together fairly closely. So I'm curious what that experience was like.
Actually, I don't think that was ever really the case.
Huh, interesting.
Square. So, relatively speaking, Square initially was the point of sale, and then we had Cash App. But the point of sale was a fairly small baseline of customers compared to like the bigger consumer apps.
Yeah, right.
So from that angle, not that important to Google. And then from the contribution angle, again, the Android team was so focused on shipping, they didn't really pay attention to, and the paying attention to the community came a lot later. And so today the landscape is very different. They're building a lot of additional tools that are amazing, but for the most part, early on, the engineers at Google, they were working crazy and they were not paying attention to the community. And so we had ties, but there were more, relationships. But I wouldn't say, yeah, it's interesting. I wouldn't say that we had like a direct, clear relationship. We had, here and there. I have so many bugs, like over the last 12 years that I've opened,
Sure.
that, so most of them just get a little bit of traffic and then they get closed as obsolete because they haven't been updated in a year. It makes me mad, to be honest. But like, I'll spend an hour, I'll spend a lot of time creating a repro case, providing details. And then it's like, we pass this on to our engineering team. 2 years later, closed as obsolete. And you're like, and the bugs are still there. Early on at Square, one of the most entertaining bugs that I ran into. So I joined the company And I didn't join to work on open source. I joined to contribute, right? So I was giving some bugs, and one of the bugs that I kept running into was some weird null pointer exception. But the thing was, we were trying to get some resources, and the resources were null, and that's not supposed to happen ever. And so, as I started looking into this, I started noticing a pattern. And the thing about me is I'm very stubborn, and I while some of our previous contributors had just like tried to quick fixes and close the bugs, I was like, I'm not letting this go. I'm gonna figure it out. And eventually, I found that there was a race condition in the app installer of the OS, where it would basically, when you got an update, the app would get so your binary is in a file, in a zip file that's called an APK. And so the way that this works is the new file gets downloaded, then the app is killed and eventually restarted on the new binary. And that's what would normally happen. But there was a race condition where while right after installing the new app and after having killed the old app, there was what's called a broadcast. So some sort of background intent telling the app to do something, it would be fired. And the system hadn't updated its references yet. So it would still wake up the old code. But then as the code was waking up, the system would then point to the new files. And so a number of things were missing. Like basically we couldn't find its own zip files because the file had moved, and that was not supposed to happen. So you'd end up with those weird situations. And the way that I found this was that I would, in the crash reports, I added report the version your current version number of the app. And I would see, so crash report would tell me, well, I asked the system for my version number, and it's new version number. But then the stack trace had line numbers that matched the old version, the code from the old version. That was mind-blowing. And the interesting thing is that bug had been there for a while, but it only started happening when Android started properly doing multi-core. And so you had more of those race conditions showing up. But yeah.
Yeah. Sorry,
that was like a...
No. I mean, I think people love hearing about bugs. I certainly do. I guess one other question in general before we get back to, what you've done at Square and Block is Android itself is open source, right? So I mean, I would imagine the existence of the operating system code itself has been very useful, right? I mean, it makes it easy.
It's amazing.
I myself, in various reasons over the years, have looked at the Android source code and figured out various things. I mean, it's just like having the Linux source code available. It's really amazing to be able to look at everything. It makes it so that you can take a lot more problems into your own hands. So I guess could you talk a little bit about, what that having access to all of that code means to you? And a follow-up question is, I would imagine at this point at Block and some of your devices, you own the entire device, right? So it's like you can patch the code if you want. So mostly just trying to understand, it's like when it comes to filing these bugs and they go nowhere, I would imagine that sometimes you just fix them, right? I mean, so it's like, how does that work?
Yeah. Yeah, that's a great question. I guess the first part, very early on in my career, I was really lucky. Before Square, I worked with an engineer, a fairly senior engineer. I don't know. I was running into some bugs, and I was like, I don't know what the framework is doing. It was probably Spring or something like that. And he told me, well, I was like, that's not in my code. He was like, well, it's open source, and you have a debugger. So let's just debug through what happens when you get an HTTP request in all of this, throughout the entire stack, right? And he showed me that, and it's sort of like, it was it's obvious in retrospect, but it was mind-blowing to me that the boundary of what I should look at wasn't just my code. I should be going through the entirety of the code and learning from all of that. And I think with Android, it's that same idea. I mean, I'm so happy that we have that when our PRs on iOS just don't have access to the sources, right? And a lot of the early, like Crashlytics, for example, like how do you handle crashes on iOS? The reason Crashlytics came to exist, as far as I know, was because someone at Apple left Apple and wrote Crashlytics. So they knew exactly how to, get that information right. But without that, it wouldn't have happened, right? And so I think that was one of the big things, was like realizing that you can debug beyond your code. Even better, on a rooted device, you can debug other processes. So like you can be like, okay, well, I made this system service call and it's not doing the right thing. Well, I can actually put a breakpoint in this other process and go through that. Sorry, what was the second question?
No, I mean, I was
Yeah.
asking more about like, given access to the code, do you patch do you solve your own problem sometimes?
Yeah.
Right.
So we have a blog post. We didn't used to do that mostly because before we didn't have our own hardware, and so we would try to provide patches sometimes, but by the time the patch rolls out, it's like several years down the line before the Android devices have caught up. We do that now for major bugs, and it's still tricky because like there's so many moving parts involved. Updating your own fork, updating you want to update the mainstream mainline. But if you look at the block entering blog, I have a colleague, Tom, who wrote a really amazing blog post recently around. We found a bug in the USB stack that's from 2013,
Wow.
and really cool bug. I'm not going to go into all of the details, but the core idea was that when you'd be on the background thread and you say, hey, I want to read, I want to read this USB stream, basically give me some bytes from the USB device. That would have the side effects of freezing the entire VM, or not really exactly. It would have the side effect of freezing the GC while doing that, while reading these bytes from the connected USB devices. And if the GC was in the midst of doing very basic operations on any threads, those threads would just get frozen as well. So we'd notice because we started seeing like, hey, sometimes the main thread is blocked for like 2 seconds for no reason. And then as we started gathering data from production, so we're getting into observability a bit, we started noticing that it would mostly happen on devices that had USB barcode scanners connected. So one of the particular things about what we do is we have all these USB devices connected. So barcode scanner, printer, a cash drawer. And so we notice it's weird. All these people using this USB barcode scanner, they keep running into these UI freezes. And then we were looking that we were able to reproduce the issue. And finally, with some traces, we could see that what was happening is there's this low level API. So when you're doing native code, and you're manipulating a data structure that lives on the Java side, you sort of have two options. Number one, you use this intermediary layer that abstract pointers. Because the problem with, you're in native code, you're dealing with pointers. But the Java layer has this GC that's moving stuff around.
Yep.
And so if you try to read a pointer and the thing's been moved around, you're reading in the wrong place, right? So you have this, either you can use this abstraction layer that abstract pointers, but then it's slow. Or you can say, hold on, I'm just going to read this binary directly. Please stop moving stuff. I'm going to read, it's going to be really quick. And then I'm going to be done and you can start moving stuff again. When you do that, you should make sure you're not blocking. It should not be any sort of blocking operation while you're reading. You shouldn't be reading from any sort of IO. And so that's what was happening in the AOSP code base. And we finally got it fixed in Android 16.
Fantastic. Love those stories. So I guess before we get into the future and the current, I mean, can you quickly just take us through some of the major things that you've worked on at Square and Block, and I don't know, like some of the things that have excited you the most there? That could be internal projects or open source work or whatever else.
Yeah, so there's that one is more like sort of like career advice. That's kind of, I like to tell the stories because it's kind of funny to me. So when I was in engineering school, I went through I knew I wanted to write code. But it was still like, okay, I got to get my diploma and all that. And so I had these signal processing classes. And I was like, it's just a bunch of math. I was like, I hate this. I just want to write code. Like, why? I'm never going to use this in my life ever, right? And so I joined Square, and after a couple of months, like, okay, cool. So here's a new reader, and it's you put in your credit card, and it encrypts that, and then it sends that as through the audio jack as a signal, and then you have to decode it on the other side. And it was like, and it was a new version, so it was doing there was a whole lot of like fast Fourier transforms, basically analyzing the frequencies of the
So
signals
you're
to figure
saying
out
that you
what it is.
should have paid attention in school.
Exactly. I
Is
was
that
like,
what you're saying?
no. Yeah. For a second, I was like, oh no. Like I knew the words, but I had no idea what to do. So that was great. The same theme, more recently, I've been focusing on performance benchmarks. And one of the things that I've started noticing and pushing people on, trying to push the entire industry on, is, hey, you cannot just take a bunch of data points from one benchmark and then another set of data points from another and like compute the mean or the median and say, well, the median moved from whatever, like 50 to 20. So it's that amount of percentage improvement. Like you cannot do that because, well, what if you run the first benchmark again and then you get a different set of points? What do you do now?
Yep.
And so you need to start talking about confidence intervals and distributions and all that. Well, that's basically stats, right? And same thing, when I was in college, I had a stats class. And I was like, I'm never using that. Like, I don't need this class, you know? So I sort of have these stories of like, in a way, yes, I did not pay a whole lot of attention. I just tried to pass the class, but I still had like the keywords and I knew that I could, learn
Right.
more about that.
So
Go ahead.
have you spent most of your time at Block working on these types of performance things, or did you spend most of your early part of your career working on product stuff? I'm just trying to understand.
Yeah,
What has your focus been over the years?
It's been product a lot until recently, until the last couple of years. But I was always doing the other fun stuff on the side.
Yeah.
Early on, we started, porting the app to tablets. I worked on the reader. I worked on a fun project. So we have these hardware readers, and we wrote a lot of code for that to connect through Bluetooth and audio jack and all of that. And all that code was very deeply connected to the rest of our code base. But we had the idea, like from a business standpoint, we had the idea that we had some customers that would very much like to build their own application and just use our hardware. And so they would need some sort of SDK to connect to our reader. And it was really hard to. So we had a couple of attempts in the past, like some teams tried to rewrite this code from scratch. Another team tried to extract it, but we were constantly adding new features. It was so hard that we never succeeded at that. And then somehow that project landed on my laps, and I did not want to do that because I was like, it's going to take me 3 years to extract this SDK. And I got a horrible idea. I thought for a second, hold on, what if I don't try to extract the SDK? What if I create a very light interface API, and then I take the entirety of the app code base and I shove that in a jar, essentially, and I call that the SDK. And that's what we did, for the first iterations. And so in a way, it was horrifying. We were doing all these crazy hacks. We were actually compiling an app, and then, because we were letting all the build tools do their job, and then we'd extract the DEX files. And so DEX is a compile, so you have your class files in from the Java world, and then that's compiled into DEX for Android. And normally, that's all happening when you compile a final app. But we were then taking those out and loading them dynamically at runtime once the SDK was initializing. And so that wasn't great, but it let us prove out that there was a business model and that we could
Yeah,
iterate.
of course. Yeah.
So that was one of the giant hacks that worked on. I'm proud, in a Frankenstein kind of way, like this monster is mine. And then another thing I did in, I think 2015 was Lee Canary. I think it's one of the libraries that is most known from what I've built. And that one was really that we had out of memory crashes. We had memory issues. And at the time, there was this tool called Eclipse Memory Analysis Tool, Matt. And so you would connect your device and trigger a heap dump, and then open that in this tool and try to explore the heap. And I kept trying. So at some point I realized, hold on, we have these objects like the activity that have a life cycle, and when they reach the end of their life cycle, you can listen to that, and then I can connect the tool and say, well, why wasn't this object garbage collected? I would use weak references to, where in the undestroy, I would create a weak reference to the object, and then after a while, I would check if the weak reference isn't cleared. I would connect the tool and try to find why. After I did that a bunch, I realized, hold on, Eclipse is open source. So what if I didn't have to do all that work manually, but I just took all of this open source Eclipse code and shipped that in the app, in the runtime, and let that do all the work of trying to do the analysis and surfacing the results to me directly. So that's how Licanary was born.
Let me ask you a controversial question. I'm just curious to get your take on it. At the time that Android was created, I mean, I think if you look at the choice of the systems language, Java, like compared to C and C++, it's probably a no-brainer to use Java for that type of system. I'm just curious, I have been around a lot of systems, both on mobile and on back end, and there's obviously a lot of pros of these types of garbage collected languages and some cons as well. And I'm just curious on your opinion at this point in the industry, with Apple obviously moving from Objective C to Swift. Do you think that Java and that type of language runtime is the right long-term future for Android, or do you think that things will evolve?
It's a great question. To be honest, I'm really bad at future stuff.
No, it's fine. I mean, you can talk
It's,
about the past. I'm just curious more about your
I
general
mean,
opinion on this space.
the reality is it makes it really nice and easy to write code, right? And memory leaks have been a huge problem in the past. They're a bit less of a problem right now, a little bit, because the way that we write code in Kotlin, we tend to do less of this, like create stateful objects that and have inner classes that have a lot of the memory leaks we had were just accidents, and the design of the language was making them easier. And it's harder in Kotlin today. It's harder to do inner classes that have hidden references to their outside class. So that part, the memory leak side, it is still, basically the memory leaks that are left today are the most complex one, really hard to debug. But another part about the GC is really its impact on the runtime.
Mm-hmm.
And yeah, I think that one is pretty bad. We are frequently noticing that, so a common issue with Android is an ANR, so application not responding, the app is freezing. One type of ANR that people don't think to look for is that they'll see an ANR, they're like, oh, what is going on? And it turns out it's just because the memory is really high because you've had all these leaks. And so the GC is just freezing the VM trying to clear out memory. And so common advice that I give when trying to figure out an ANR is first check the memory level. If it's very high, don't look at the stack trace, just like you have a memory leak problem. And the ANR is just a step towards the out of memory crash.
Right. Yep.
Beyond that, it is very nice to have a GC, like not have to think about those relationships. And our friends on iOS, I see them chasing a lot of memory issues as well. They're different ones, but they have their own problems.
It's a very interesting space, and it's one that I don't know as much about. I know that on server, obviously, there's been a huge investment in like Grail VM and like other Java runtimes that are a lot more efficient in terms of how they do pauseless GC and all of those things. I don't know the current state of the art. You probably do in terms of whether some of those technologies are being brought to the phone. Like, do you know, are they working on bringing some of these advancements to the runtime that actually runs on Android itself?
I know they brought a bunch, but I don't know the latest on that. It's also, it's always trade-offs between the types of hardware you got, the amount of memory you have.
Absolutely.
Number of CPUs. And so, Android already has, concurrent GCs, and they've got local thread, when you're allocating, you'll typically have a thread local buffer. So you're allocating there first. There's a whole bunch of mechanisms in place to make that nice. But I don't know compared to like what's the latest in the GC world. I'm not super familiar with that, to be honest.
Yeah. Okay, cool. So, I think what I'd like to chat with you about next is, obviously it's clear so far in this conversation that you have a lot of interest in performance and general understanding of systems. What I'm curious about is, you work at a company that has a lot of engineers, and I'm sure you face lots of problems, right? From like long build times to developer productivity to like observability to performance. And I guess I'm curious, you yourself are clearly focusing on the performance side, but obviously as an organization, I'm sure you face lots of issues. So I guess I guess it's a two-part question. From an engineering organization perspective, what do you think are the biggest problems facing mobile in general right now? And then I guess for you yourself, how do you choose where to focus on that menu of problems? Because you're obviously a very senior contributor, you have some leeway in terms of what you work on in terms of its impact. So I guess I'm curious again, like the menu of large problems that you're facing right now and how you've chosen your current focus area.
It's interesting. I mean, it's always changing. I guess actually, the second part is easier for me to answer because mostly it's the gaps, right? So, for example, it used to be that our build and ID situation and CI situation was terrible, and it's just that, and today it's not because we have a team that's doing a really good job there. And honestly, it's mostly having the right people, the right manager, and there's still a lot to do there. But I'm giving you that as example of like a couple years back, our builds were on fire. Um, and today it's mostly fine and they keep improving things. And I'm like, thank God. Like, but yeah,
Sorry, when you say on fire, took a long time or breaking all the
yeah.
time? I'm just, like trying to understand what was the
Really,
problem
yeah.
space there.
What we had was builds were very slow. That would be like maybe 5 years ago. Builds were incredibly slow and IDE sync times were slow. IDs were slow. You have to think, there's at the time maybe 50 engineers, 50, 70 engineers contributing. Everyone has a different IDE configuration. Some people are trying the latest, some are in different build versions and things. And so like Gradle version. So it's really hard to debug what's going on. Everything is slow. Gradle at the time was slow. And what happened since is that we started giving them the Gradle team, we gave them demo projects that reproduce the biggest issue, and they started addressing all of the core issues. At the same time, I think we tried Buck for a bit, but without having the deeper knowledge of how to use Buck, how to set it up. And the biggest thing that happened is one engineer was created this concept of feature modules. The idea was when you work on a new feature, instead of contributing to like the couple modules we have, you're going to create a set of modules, one for your public API, one for your implementation, and one for like a small demo app that only runs the implementation code of your module. And you won't have many transitive dependencies. You'll just have direct dependencies to API modules that have a fake version of them, right? So this makes a lot of sense. But as soon as he did that and he created utilities to quickly create those, every engineer was using those because you were switching from like 5-minute builds to like 30 seconds, right?
Right.
And so that led to a huge increase in the number of modules, which made things worse for our build team at the time. Because like all of a sudden the builds was the biggest build was slowing down. This was just fixed by doing what you do as any engineering team, which means taking problems in the right order, sitting with customers, doing things like standardizing the tool so that everyone uses the same tool, hiring good engineers who know how to debug stuff and who actually get into that and fix things. So they did all that. So that was an example of like, this used to be a problem. Still is, a lot of investment, but I don't feel concerned about that. And so what I am looking at today is a lot of performance and observability. And the primary reason is because historically, we haven't been terribly good at that and at investing there. And so I'm trying to push for that. And then, I think the obvious one that's coming down the pipe is the impact of using LLMs to
Of course.
generate code and how it changes the practice. Because, at Block, so there's nothing like, hey, if you don't use LLMs, you're going to get fired or anything like that, right? But there is a push for like, this is a tool should help you with productivity. You should get to learn to use it. And everyone's constantly questioning like, oh, should we use it for migrations, which is a really interesting use case.
For sure.
Versus new features. The biggest question though is, are we going to be introducing, it's the same. It's like doing things in reasonable ways. And so like, are we going to start seeing a whole lot new code being introduced, and how do we ensure a high quality bar?
I'm not an AI doomer by any means. I think these tools are real, and I think they will increase productivity over time. At the same time, My personal experience so far, it has not lived up to the hype, and I don't know if that's just me. I do use these tools on a daily basis, and they do help me in certain things. But the world in which, especially for sophisticated, large existing code bases, where you're like magically generating all the code and not shipping more bugs than you would have had previously, is not super clear to me currently. So I
Um,
don't know.
I'm in the same boat. And every time I surface something, I hear you're using it wrong, and I'm like, well, at some point, if the tool cannot be used right, like,
Well,
uh,
I mean, it's actually funny that you say that, because in our small company, we have a Slack channel, like, just for helping each other use AI, and we talk about our prompts and all of these things. And like, there are times in which I'm typing there and I'm saying, like, I kind of feel dumb because I read online that everyone says that these things are supposed to be amazing, and it's like it's not working for me. So
mhm.
am I just doing it wrong? But to your point, if like I'm a reasonably smart person. If I can't use the tool, then maybe the tool
Yeah.
is not quite right yet. Anyway,
Yeah, I guess to me, there's just two things. I've seen two fairly interesting use cases, at least that for now work for me. Number one is, and I think that's what most people have started using it for as well, is like stuff you're remotely familiar with, but not an expert at, and it
absolutely.
helps you
Yeah.
like get started, right? So like I talked
Hmm.
about stats, and I was recently throwing some data set at ChatGPT, and I was like, write me some Python code to run this type of analysis, that type
Hmm.
of analysis. And it's sort of like helping me, and also just learning a number of things, and then asking for like the code and where is that information coming from and all that, and starting to build a mental model. And then I
Yep.
know I can take that code and turn that into something more production ready. So that's one thing. Like anything you're on the frontier and you're not an expert, where I would normally need to go find a statistics experts at my company, which either they don't exist or they don't talk to me. Like I don't know how to find these people. I think that's number one. And then number two, I saw recent example that I'm really excited about. So we released this thing called Trailblaze, and the key idea is writing UI tests. So there's this tool called Maestro where you write UI tests as sort of like little commands, like do this, do that, do this. It's meant to be
Yep.
editable by a human, and it can run on Android and iOS. So that's nice. But the idea was, but you still need to describe what you're expecting to see in the UI and what actions to do. Using an LLM to generate that, going from English sentences to that, but in a way where you write your sentence, the LLMs generates those commands, they're run, but then what gets checked in or remembered is those commands.
Yep.
And then every time the test run, it runs from those commands. And when the
Yep.
test fails, you can rerun the LLM loop and say, hey, try again, like maybe the UI has changed, maybe you can figure out, and if the LLM
Right.
can't, then you can go back and actually look at what's broken. I think
Yeah.
it's super interesting.
Yeah, I mean, I have no doubt that there are going to be very real good use cases. And my personal experience is that 99% of the value I get is what you said, which is just having a buddy that I can do a Q&A with and just expedite my learning, right? It's like it helps me learn faster. So I think there's a lot of value there. In the little time that we have left, I do want to come back to the performance side. So, you were talking about that's your focus now. I think one question I have is, this is a very high level question. I think intuitively, we as senior or sophisticated engineers, we know that performance is important. There's been many studies over the years that show that performance of applications and systems directly contribute to conversion and all of
Yep.
those things. At the same time, it's very difficult to equivocally prove, right, that like you do X, Y, or Z with performance and it is going to, improve business goals and all of those things. So I'd love to just understand from you, when you work on this topic, you clearly think that it's important. I guess first, why do you think it's important, and how do you justify to the company spending your time like working on these things?
Yeah, that's a great question. There's a couple things there. Yes, there are a bunch of studies, but like it's studies from Amazon and like drop-in carts usage and all
Yep.
that, and
Right.
it's great, but it doesn't map to like many apps, and so
Yep.
it's kind of hard to translate that. Okay, so this is very hard. First of all, translating back, like doing like trying to be data first on this. I'll give you one example, especially with our type of customer. when our customers use us, we're like a very integrated solution. So we're basically saying, hey, with us, you get everything. And you don't have to worry about anything. Everything is connected together. It's like an amazing experience, right? And we have competitors. And so why do people switch to competitors? Well, if your performance is bad, the customers will rarely say, oh, the performance is bad. Typically, what will happen is um, the competitor has cheaper prices.
Yep.
They have a reason to go, and they'll just go and they'll say, well, cheaper prices or missing feature or what not. But when your customers love your app, like, so we're serving small businesses, they have other things to do than trying to focus on the app. They just want to get things done, and it's just got to work, right? So when it works fine and that's not a problem for them to handle, they don't care that much about the slightly lower price or, that feature that's missing, unless it's very blocking. So when you have bad UX, performance problems, they're not going to say, I'm leaving because of those. But they basically are not a loyal customer anymore, and they're ready to switch anytime. So in terms of churn, it's going to be really hard to connect that data, because they'll say, well, lower prices over there. But they were long gone. Before that, they just stopped, being engaged with the product. And it's hard to see because they're still using it. But I think you can tell that story. And so I tell that story. And also we've had, sometimes we had an important customer leave us, or someone that matters for us. And it's usually a good time to look into what has their performance experience been, and sort of bring, show the data side of things, but tell a story around it. Like, jump on the story and talk to execs, talk to PMs and say, hey, they talked about having problems with the app. Did you know that they were running into this and that and this? And sort of like building the bigger story. You don't always need to have the proof in the data, especially when you can't really. And then the other thing that I've done a lot is look into, there's a number of studies, and you can also experiment for yourself around what does it mean to have a performance issue, right? So like, for example, with mobile devices, when, touching the screen of your phone and all that, it turns out humans can't, so the delay between when you touch and when the UI responds, humans can't really perceive any difference at all below 69 milliseconds. And really, you can round that up and you can say 100 milliseconds is totally fine for tap response. For motion, you really just don't want, so like scrolling and all that, you just don't want to miss any frames until the hardware gets like a lot better, but we're not there. So that means you can pick that, and that's actually what Apple recommends, 100 milliseconds, or you can pick like a bit higher than that. But you can say, hey, when we're below that, it doesn't really matter. When we get over 300, 400, 500 milliseconds between the time I do a thing and the time the UI responds, that's noticeable. And what it changes, especially for us, like we're building tools. We don't want people to be focused on the tools. We want them to use muscle memory and just tap, tap, tap without thinking, right? But if the UI takes a while to respond, you're tapping and you learn to wait and pay attention, and you're not focused on engaging with your customer, right? So that's kind of the story that I tell. And I built a bunch of demo apps internally that would show, hey, here's what the interaction feels like when you have that type of delay. And if you put that in the hands of someone, they'll be, oh yeah, that's bad. So you can kind of justify the thresholds you're using as targets that way.
I mean, what you're talking about is something that obviously as a company, we talk about all the time, which is that, and I guess maybe this is where we can close out, just get your opinion on this, is I feel like from a mobile industry perspective, and maybe this is because of what developers are used to or the tooling or all of those things, but obviously like crash reporting is the thing that people know, right? I mean, it's like, at least historically, crashes are what mobile developers care about. And I think what you're describing is something that we talk about all the time, which is that in mature applications, actual crashes are a tiny fraction of the problems, right?
Yeah.
It's like slow UI, like things that don't work, just frustration, quits, all of those things. And I think, I guess as we close, I'd love to just hear from you, like how you think about that, right? Because you clearly are looking into a lot of these non-crashing issues. So it's like, how do you think about, the industry's almost historical obsession on like crashing versus the types of problems that you can argue on not that crashes aren't important. Obviously, a bad crash is very important, but the type of things that you're talking about impact all users, right?
Yeah, I mean, I think
Yeah.
it's the joke around the person who lets their keys and they're looking right on the light and I forget, someone asked them like, why are you looking here? I'm not telling the story right, but like they're looking right under a light at night. And where did you lose your keys? Oh, over there, but this is the only place where there's light, so that's where
Right.
I'm looking.
Yep. Yep.
I think that's
Yep.
the same story, where for the longest time, the easiest signal to get was crashes. So we got crashes, and I've surfaced many times. I don't think either Apple or Google did a great job enabling observability, enabling getting people to understand what's happening into their apps. We've left that to vendors, which historically have not had a very big mobile background or deep understanding of what happens in mobile app. And so have built tools that there are a number of vendors that have mobile tools that have side effects that will, you're trying to see if your app is good or not, and you enable the observability tool and it's tanking your app, right? So I think historically there's just been a lack of focus from Apple and Google, and crash reporting has been easy to implement. So that's what people have been looking at. We took this interesting approach at Block of like, we call that crash fast, which is the idea that, offensive programming. It's this idea that if something's wrong, you just crash instead of trying to recover. So if something is null, instead of trying to say, well, don't show the UI, don't show this pop-up if the thing is null, and then you end up with like a user pressing a button and nothing's happening, and you don't even know that because there's just no signal. Crashing is bad, but at least you get the signal and you're going to work on it. And so I think that's why crashes are like,
I was gonna say real quick, that is my general philosophy also. Until you write an SDK that runs in other people's apps,
and people get mad at you. Absolutely.
At that point, crashing is real bad.
Yeah. No, I hear you. Different story. But anyway, I think that's primarily that's the signal we got. So it's this thing we fix. And I think, I know everybody's focused on AI, but I think there's this parallel timeline of like the next big thing for mobile is also observability.
Yeah. Well, cool. Thank you. I could talk about this all day, but in the interest of time, we have to wrap up. Any final parting words, any hot takes that you'd like to share about the future?
Not really. I think I'm still excited for the future. I think I was I was at DreadCon recently, and I said that I love bugs. Like everything I learn, I don't typically sit down and go learn new technologies. I learn them when there's a bug and I need to investigate because someone else used the new technology. So I love bugs. And that's what my career has been made of, learning how to fix bugs, investigating bugs. So I'm excited about the future because LLMs are likely to introduce a whole lot of new interesting bugs.
More bugs. All right. Thank you. It's a great way to wrap up. So anyway, thank you so much for joining us. This was fantastic. And that's a wrap for this episode of Beyond the Noise, Signals, Stories, and Spicy Takes. Huge thanks to PY for joining and sharing your story. You can find this episode and all past ones on the Bitrif YouTube channel. And if you had fun, drop us a review, tell your friends, or yell your favorite hot take into the void. And just make sure to tag us. I'm Matt Klein, and I will see you next time. Thank you so much.